for our whiteboard meeting. So anybody has anything that they want to talk about? Like, there are a couple of things you can do. One is you can share your strategy for how you went about solving the problem. That's one possibility. Another possibility is you can ask question of somebody else of their boards. And if you don't know who the person is, you can just say, hey, on board number 2, I saw this and I don't understand, right? This is your chance of talking to one another about how you went about solving this problem and what you found and what you understand, what you don't understand. So go. Who wants to talk?
I got you. Oh, okay. So, hang on. It's not very big on my screen, so I'm gonna go get mine. Pull it up. Okay, so this one here, you can kind of see, I think I'm selecting it. Yep, that one. That is, I don't know if that's Elliot. I think that's Elliot's. Is that Elliot's or is that Natalia's? We never really talked about it. It was just there.
I think that's Natalia's.
Okay, that's Natalia's graph. And over here, Natalia was helping me figure out my equations for my problem. And this one's Elliot's. So yeah.
Vivian, can you talk to us a little bit about your strategy for solving this problem? Like, how did you think about the problem?
Well, I was thinking about it originally in like how could I turn this into like a motion map? But I did it wrong. And then
what did you do wrong?
I put so okay, let's see if I can explain this. The first one I got the time offset and the space offset mixed up. So I had a 1 mile space offset when it was supposed to be 4 miles. And I also had a 1 hour time offset. So I had to fix that. And then for this one, I had like I think I had their position switched. So David was supposed to start before Kelly. But I had Kelly start before David, which wasn't supposed to happen. So then when I went over it with Natalia, she was like, oh, it's the other way around. And I was like, oh my God. So yeah.
Okay. Anybody else? I mean, right now I'm on room 4, but I can move to any room anybody wants to. Any strategy, like how did you guys go about solving this problem? Because that's going to be the most helpful for people who are stuck. Yeah, go ahead.
For me, I did kind of an, just to start out before I graphed it, I did like an XY table of the coordinates. So when I was placing, it would be easier to find the exact point of intersection. And also for an equation, it's easier when you know exactly what the points specifically are.
How did you go about finding the coordinates?
Oh, well, so I looked at the space and time offset. So I knew that David started at 4 for me, and Kelly did not start at 0 on the x-axis. She started at 1. So I kind of knew my first, I guess, 2 points. And since David goes up by 4 each time, he has a +4 on that, and then it's +8 for Kelly. So I just went through after that like that. So
cool. Okay, so you started with did anybody else want to start with a table? Yeah, Natalia?
I started with my graph, so I just like did the first point, and then I kept on doing like that triangle where you like go over one and then up the amount. So that's what I did.
So the rise and the run?
Yeah. That's
for each time interval. Okay, that's interesting. So that was your strategy. So your strategy was you did a graph, and then you went from dot to dot by doing the rise and the run, and you knew like the time interval, so you knew how much distance you would cover, which is kind of what Elliot did with a coordinate system, right? Anybody else? Yeah, Molly, what picture are you on? What room were you in?
I think 3.
Okay. So talk to us.
Yeah, so mine is like the blue looking one. What I did
Yeah.
was the distance is the bottom line and the time is the upper line. And what I did is I just kind of figured like because Kelly's going 3 miles per hour and each thing represents an hour, like or a mile. So I did 3 miles and then I went up and then I did another 3 miles and then I went up. And so I made that a line. And then for David, he goes 2 miles per hour. And I put him on the offset of 10 because I was supposed to do an offset of 10 miles, but I was kind of confused about time offset, although it got explained. I'm still a little bit blurry on it. Although it's like when he's, so I should have put it up one. Anyway, I would go up one, and then to the left 2 because that's 2 miles per hour.
Okay, so you did a graph and your horizontal axis was position and your vertical axis was time, which is interesting. It's the reverse of what we've been doing, but as long as you're clear and as long as you label. But again, and you did the same thing that Natalia did, which is you did the rise and the run, except of course for you, the rise and the run are going to be switched, right? I mean, your rise is going to be her run and vice versa.
And I thought it was really interesting. I really liked how the people, I don't know exactly who did it, but it was y equals. And I thought that was a really good use of whatever that is called.
Like this here?
Yeah, I thought that was really smart. So
like the equations? Yeah, so people who did the equations, like, can you talk to us a little bit about how did you go about finding your equation for your graphs?
So for me, I already knew what the slope was going to be because that's just the miles per hour. And then I just so for me the space offset was 10 miles, so David would technically start at 10. So that was my y-intercept, so that's how I came up with David's equation. And then for Kelly, I kind of just extended the line going downward and kind of ignored the time offset. So I got, I believe, -12. Yeah. And then I just made them equal each other and then figured out what x was and then plugged in x into the equation to see what y was. So
okay, so what I'm hearing is that one of the strategies you used is for David, since he starts to move at 0 seconds, his position at the beginning is actually, in fact, that's the y-intercept.
Yeah.
Right? So for him, since you know his speed and you know the y-intercept, that's a really easy equation to solve, right? Like to set. And then you said that for Kelly, what you did is you knew that she started with a time offset. So she's like, for example, in this curve, in this particular graph here, right? You see that this is where Kelly starts, right? Assuming that would be, so there's an offset here of 2 hours, right? And so what you did then is you just, made the line go further down that way, and then you figured out where that would intersect, and that's how you got the equation. Clever. Anybody else wants to talk about the boards or their boards or any of the questions that they found? Yeah, Natalia.
So on slide 2, on the Desmos example, I was wondering how they incorporated their time offset because wouldn't it cross the x-axis?
In fact, I would have that same question. In fact, I believe I asked that question on Canvas. I have that question for both on slide 2, right? If you guys look at both graphs, whether it's a Desmos graph or whether it's the graph in the notebook, you notice that both ones have a picture that starts here and that starts there, right? And that means that somebody is starting at time t equals 0 to move with a certain amount of speed, which I don't believe is a thing. David starts to move at t equals 0, but he's further up on the line. And Kelly starts to move, but not at t equals 0. She starts to move after the offset. So that's an interesting thing. So I'm not exactly sure who came up with those two things, but people who made those boards, do you have an explanation for us?
Yeah, I'm the one in the notebook. I'm actually redoing it like right now because I realized that earlier.
Okay, cool. That's awesome. Okay. Anybody else? Like room one had lots of still in progress, which is fine. Like that's what we, it's totally fine. So interesting, Marika also had, right? So she has, so Marika, you had, let's see. I'm trying to understand. What was your offset, Marika?
10 miles.
10 miles. Your graph looks like it's intersecting at 8. Is that on purpose or?
Probably not.
No, I'm just asking, right? Like you have I mean, again, like and it looks like the Kelly graph is starting at 0, 0.
Yeah.
So that's going to be a problematic. Did anybody have like a completely different way of thinking about this problem? It's like some people started with motion maps, some people start with equations, some people start with the graphs. Did anybody think of a completely new way of thinking about the problem? Like something that we haven't talked about?
Well, I thought of it like mathematically because, like, you
Okay.
can see in mine, minus Tara, you can see I got really confused because I thought we were doing it in seconds and I was like very confused. And I was like, that's gonna take a while. But then Vincent told me that it was in hours. And I was like, oh, that's a lot clearer. But I wrote down on the bottom, I wrote down what I was thinking. So basically what I said, he will start at 5 miles because that's his set distance, and Kelly
Yeah.
will start at 0 miles, and then I guess I just did a point underneath, and then he goes 2 miles per hour, and so he would, and the 1 hour that Kelly couldn't move, he would have traveled 7 miles. And then after that 1 hour, Kelly would have moved, and they both would have moved, and Kelly would have done, for the second hour, Kelly would have had her first 6 miles, and the D person would have moved 9 miles. And then the third hour, the D person would have moved 11 miles and Kelly would have moved 12 miles. So they would have met in between 11 and 12 miles.
Cool. So that's going to be something that's going to happen to you if you start thinking in terms of motion maps. So what you managed to do is you managed to bracket, like it's happening between hour 2 and hour 3, right? If you know exactly where the points are at hour 2 and hour 3, that's the time at which you can start shifting to like a smaller time interval. So instead of now working by hours, maybe you work in like 10-minute increments, or you work in like half-hour increments, or you work in, because you know exactly where the points are. So from there, you can shift the time time steps to be smaller, so you can have a better definition, which would be a good thing. So one thing that you guys can think about, for example, and there are a bajillion ways to solve this problem, right? But one is, for example, to say, well, let's say Kelly is running after, David, and let's say that David is running at 6 miles an hour, and Kelly is running at 8 miles an hour, right? So you can like make a motion map where like they're both like running after each other, and we know that Kelly will at some point catch up with David. But if you think about it, for somebody to run 6 miles an hour and somebody running after them to run 8 is the same thing as if the person who's running at 6 miles an hour is not running at all, and the person running after them was running 2 miles an hour, right? Because essentially what you're doing is you're saying the difference between Kelly and David would be 2 miles an hour. So if David never moved and Kelly started moving 2 miles an hour, then that's the same scenario. And I don't know if that's going to help, or if somebody's running 6 miles an hour one way and somebody else is running 8 miles an hour the other way, and they're moving at each other, it's the same thing as if one person was not moving and the other person was moving 14 miles an hour. Like, it doesn't matter, right, how you split it. Like, it's just the time, the speed difference between the two. So it is 11:03. I'm going to stop recording because